radar screen goes blank. For 8 critical seconds, every surface-to-air missile battery within 300 miles loses track of its target. When the signals return, the bomber has vanished, not destroyed, simply invisible. What you're witnessing is the future erasing the present, a quantum leap so profound it makes 5th-generation fighters look like museum pieces. 8:47 hours, Edwards Air Force Base, California. March 2025. The most expensive arms race in human history just entered its final phase. While headlines obsess over hypersonic missiles, the real revolution is happening 35,000 feet overhead, where 3 nations are burning through hundreds of billions to build aircraft that rewrite the rules of what's possible. This is the 6th-generation fighter race, and the winner controls the skies for the next half-century. The strategic equation is brutal. China's churning out J-20 stealth fighters at industrial scale. Russia's hypersonic glide vehicles travel at Mach 20. And America's F-22 Raptors, the apex predators of 2005, are aging into irrelevance against threats that didn't exist when they were designed. 6th-generation fighters aren't upgrades. They're a fundamental reimagining of air combat platforms, blending stealth, artificial intelligence, and swarm coordination into weapons systems that command fleets of autonomous drones and engage threats at ranges that make dogfighting obsolete. The F-35 costs $80 million. The coming generation, $300 million per aircraft, with AI co-pilots processing battlefield data faster than human thought and networking capabilities that turn each fighter into a node in a combat cloud spanning continents. The US calls it NGAD Next Generation Air Dominance. Boeing just won a contract worth tens of billions to build the F-47, a fighter that Air Force generals claim can hit speeds no other aircraft has achieved. Potentially Mach 5, hypersonic, with adaptive cycle engines that reconfigure mid-flight and internal weapons bays, hiding munitions that can strike targets 1,000 miles away. But NGAD isn't flying alone. Each F-47 commands up to 4 collaborative combat aircraft AI-driven drones that extend the fighter's sensors, carry additional weapons, and absorb enemy fire meant for human pilots. One manned jet becomes a 5-aircraft strike package, multiplying lethality while distributing risk across expendable platforms. The Air Force plans 200 NGAD fighters and 1,000 loyal wingman drones. Total program cost, over $150 billion, possibly approaching $1 trillion with decades of operations. Compare that to China's approach. December 2024, observers in Chengdu captured footage of a mysterious tailless flying wing prototype, sleek tri-engine, unmistakably 6th generation. Analysts dubbed it the J-36. Weeks later, a second design emerged from Shenyang, then a third in August 2025. China's running at least 3 competing prototypes simultaneously, a multi-billion-dollar parallel development betting they can match US capability by 2035. Chinese military officials are explicit. Their next fighter will feature omnidirectional sensors, AI integration, loyal wingman swarms, and multispectral stealth. They've studied every American advancement and concluded that 6th-generation warfare demands system of systems thinking, where fighters, drones, satellites, and cyber assets merge into a distributed force no single platform can defeat. Beijing's defense budget hit $230 billion in 2024, increasing 7% annually for nearly 3 decades. Europe answers with 2 massive programs. The UK, Japan, and Italy formed GCAP Global Combat Air Programme, merging Britain's Tempest project with Japanese technology to field a 6th-gen fighter by 2035. BAE Systems, Mitsubishi, Heavy Industries, and Leonardo are building a stealth jet with optionally manned capability and data links, transmitting 10,000 times the information of current systems. The partners are splitting roughly £50 billion in development costs. Meanwhile, France, Germany, and Spain pour over €100 billion into FCAS Future Combat Air System. Dassault and Airbus lead development of the next-generation fighter, accompanied by remote carrier drones and an air combat cloud network. Target deployment 2040. The program nearly collapsed twice over industrial disputes, but the political imperative is overwhelming. Europe cannot concede air superiority to America, China, or anyone else. These aren't just fighter jets. They're flying supercomputers wrapped in multispectral stealth, low observable across radar, infrared, acoustic, and visual spectrums. Where F-35s used passive coatings, 6th-gen aircraft employ active camouflage, dynamic materials that adapt signatures in real time. Smart skins distribute sensors across the entire airframe, providing 360-degree awareness that feeds AI algorithms trained on millions of simulated encounters. The weapons redefine engagement. Hypersonic missiles traveling Mach 5 and beyond give enemies virtually no reaction time. Some concepts include directed energy weapons, compact lasers for shooting down incoming missiles at light speed. And unlike 5th-gen fighters limited by internal bays, 6th-gen platforms coordinate with drone missile trucks carrying additional ordnance. The true revolution is optionally manned operation. These aircraft can fly with a pilot commanding the battle, or autonomously under AI control for missions too dangerous for human crews. A 6th-gen fighter might penetrate enemy airspace unmanned, using its sensors to paint targets for forces hundreds of miles away, then egress without ever risking a life. The US shocked the world in 2020 by revealing it had already flown a full-scale NGAD demonstrator, using digital engineering designing and refining in virtual environments before bending metal. That compressed development cycles from decades to years. When the lead F-47 opens its weapons bay, 2 hypersonic anti-ship missiles drop free. They accelerate to Mach 6, becoming effectively invisible to point defenses designed for subsonic cruise missiles. The Chinese destroyer's radar operators see nothing until the weapons materialize 8 seconds from impact. The missiles punch through the superstructure, 450-pound warheads detonating among radar arrays. Simultaneously, loyal wingman drones launch coordinated strikes against Chinese air cover. AI-directed beyond visual range missiles streak toward J-15 fighters from multiple vectors. The Chinese pilots never acquire their attackers. Their radars are still sweeping empty sky when the missiles impact. In 4 minutes, the formation transitions from confident patrol to scattered wreckage across 20 square miles of ocean. The aftermath ripples globally. In Brussels, NATO planners realize Norwegian F-35s can share targeting data instantaneously with British 6th-gen fighters and Italian platforms over the Adriatic. An integrated air defense network spanning Europe becomes possible, overlapping coverage that Russian 4th-generation aircraft cannot penetrate without prohibitive losses. But 6th-generation capability demands unprecedented industrial effort. At Lockheed Martin's Fort Worth facility, production lines operate around the clock. Technician Sarah Chen calibrates helmet-mounted displays, giving pilots superhuman vision. Former Marine pilot Colonel James Rodriguez oversees flight test operations, drawing on 20 years of combat experience to refine tactics that will keep future aircrews alive. At BAE Systems' Samlesbury facility in Lancashire, software engineer David Thompson leads teams responsible for electronic warfare systems that must defeat threats that didn't exist when development began. His algorithms determine whether an F-47 can detect, classify, and counter China's PL-15 air-to-air missiles and Russia's latest S-400 variants. The supply chains extend across continents. Pratt & Whitney's Connecticut facility produces adaptive cycle engines using metallurgy that didn't exist 5 years ago. Northrop Grumman's Palmdale plant operates robotic systems fabricating center fuselage sections with tolerances measured in thousandths of inches. The NGAD program alone supports 254,000 American jobs across 48 states. GCAP and FCAS collectively employ hundreds of thousands more across Europe and Asia. The strategic implications are profound. For 70 years, nuclear deterrence rested on mutual vulnerability. Both superpowers remained safe because both could be destroyed. 6th-generation air dominance breaks that equation. If America can neutralize incoming threats while projecting power globally, it fundamentally alters international relations. History suggests revolutionary technologies reshape world order. The atomic bomb ended World War II and created the Cold War's bipolar structure. Precision-guided munitions enabled America's military transformation in the 1990s. Sixth-generation fighters may prove equally transformative, ushering in an era where geography and distance matter again in ways they haven't since the dawn of the missile age. The costs are staggering, hundreds of billions burning through budgets, but the alternative is unthinkable. In air combat, second place is first loser. The nation that controls the high ground in 2035 will shape global events for the next half-century. If you were advising the Pentagon, would you prioritize even more advanced technology to maintain the edge, or pursue arms control to prevent runaway competition? Is air dominance worth the price? This is DIB Dispatch, where billion-dollar projects meet battlefield reality.